we are we are understanding force. It is not a only word. It is a you can say a big chapter. About it, I would like to discuss with you. Force word, as you can say, we will understand what will be discussed in this slide. Firstly, I would like to tell you what topics what topics will be covered in this slide. I want to tell you. First, we will understand force, types of a force, and more about it. Okay, meaning of a force we will understand. Motion, taste of something, motion, object is in motion. About all this, we will be exploring in this slide. Types of force as well as effects of force we will try to explore. Okay, what can be done by applying force? That's it. uh, about that we will understand after completing the force topic. We will explore laws of motion. Laws of motion, you can say Newton's law, Newton's first law, Newton's second law, Newton's third law. All third laws, all three laws we will explore, we will dive. Okay, we will explore in details laws of motion. Second, so first Newton's law, then we will understand second Newton's law, then third Newton's law. After completing fourth chapter, here remember why are we taking both topics together in this slide, because both are connected to each other. That's all. Okay. When we will understand force, types of force, effects of a force, then we can connect concepts of force with the laws of motion. We can connect. I'm not saying completely we will connect, but there will be connection of this with this. Remember. Now let's begin from force. Let's begin from force. What do you think about it? I know uh, most of you don't know meaning of a force. Okay, don't feel nervous. Just try to explain. According to you, what do you think? What do you think about the force? According to you, your definition can be different from other person, from me. But try to explain. As much as you can give logic, you give logic. Then your explanation will make sense. Okay, if you are making mistake, then it happens. Okay, it happens with many students. But my point is, just try to explain. If you don't know something, little some words can you say? Some words about it can you say? Now, let me tell you meaning of this. It is just a pull or push. Force. Our force is what we apply like that. We pull like that. We push like that. So here we are doing what? We are applying force. It is a force. Force can be two types. I am not talking about types of force, gravitational force, magnetic force. No, I am not talking about all this right now. Here we we push something, we pull something. Meaning of this is what? It is a force. In one word, we say we are applying force. Yes, we can pull something, we can push something, isn't it? Now, standard meaning. Let's move on. Standard meaning of force. Of a force. Remember, if we are applying force over any object, then that object will move. Obviously, that object will move. When external force will be applied on an on object, then that object will move. And surely that object was here, and after applying that object will be somewhere. Will be somewhere. So it happened. Here you can observe position of an object is changing because of applied force. Because of applied force. Force was applied on that object. That's why object moved towards any direction. So this is a standard meaning. Yes, if object is moving, if object is being moved, it means that motion will take time. Always remember, rest will not take time. Motion will take time. We will understand it in details in next standard, in also next chapter. After that, next standard, we will be exploring motions, not rest. And when we will try to understand concept of motion, concept related to motion, then always remember motion will take time. If motion is taking time, it means in formula time will come. Of course, in formula time will come. Anything is moving. It means that motion of object is taking time. Now here, when external force will be applied on any object, that object, of course, that object will move in any direction. That object will move in any direction because external force was applied. That's all. Clear? This is the standard meaning of a force. Sometimes we can pull. So here we are pulling something. Now you can observe that object was there, and when I pulled, when I did pull this object, then it moved towards me. It doesn't matter you are applying push or pull. Both will come in the category of both will come to define force. Both push or pull, both this will come to define force. It is a universal truth. In some words, you can remember meaning of force. It is just a push or pull. It can change something. It can change something. Do you want to see what changes can be done by applying force? I will tell you. It can change. Now here, we are understanding what push or pull. The both are what? Both comes to define force. Yeah. somebody is applying force, what will happen? Somebody is applying force, what will happen? Position of an object will change. Yes, what else? What else? That's it. Now, even go. Effects of force. Effects of force we will try to understand. Before that, I would like to introduce motion and rest. I told you force is being applied on any object, it means that object will move. And that object is moving, it means that object is moving, it means object in motion. Object is in motion. Now try to observe carefully. Try to observe carefully. What is happening? When force is applied on any object, so before applying force on any object is in rest. Any object is in rest. Object is in rest, and when we will apply force, then that object will come into motion. It is happening. What is that? That is happening. When force will be applied, then that object which was in rest will come into motion because of force was applied. That's all. So it will happen when force will be applied on any object. If object is in rest, then that object will come into motion. Now, what else can be observed? Sometimes you will be observing what object is coming to you. What will you do? You will stop that object which is coming to you. And how will you do? Just like that. So here you are pushing. You are not pulling. You are pushing. Why you are pushing? So that you can stop. So that you can stop coming ball. Yes? Am I right? So here object was in a motion. Object was in motion. Now when object was in motion and when we applied force, then that object came into rest. How did it happen? How did it happen? Can you tell me? You would say it happened because of force. Force word is coming many times. Yes, force word should come many times. No. What did we understand? We understand if object is in rest and when external force will be applied, then that object will come into motion. Initially, object was in rest, but when external force was applied, then that object came into motion. It happened that object came into motion because of force was applied. That's why. Now, what if object is in motion? If object in motion, then what about this? Look, If object in motion, then of course it will be in motion. But when external force comes in, comes to apply on that object which is moving, which object is moving. Now object is moving and external force, I am applying external force, and I am applying external force so that I can stop that object. Now here you don't think that only to stop motion, object in motion, and you are applying force only to stop. Even you can apply external force to accelerate that object which object is moving. To increase a speed of any object, you can apply external force, not only to stop. Clear? What do I mean? If you didn't understand, then I would like to repeat it again. If object is in motion and we don't want to stop, then what do we want? We want that a speed of that object should be increased. Then we can apply. And then we can apply what external force. Like if an object is moving and we want to increase the speed of this object, then we can apply like that force. Then now what will happen? A speed of moving object will increase because we applied external force. Right. So here are you able to observe what is happening? Moving object object is moving and we can stop that object by pushing like that. Now that object which was in motion came into rest. It happened. It is the nature. It is happening in your daily life. A lot of objects are moving surrounding you. A lot of objects are in rest surrounding you. Isn't it? Yes, it is happening. Did you understand? If object is in rest and external force is applied, then that object will come into motion. Now object is in motion. When external force is applied, then object can be stopped by applying external force of moving object. A speed of moving object can be increased by applying external force. It is a true or not? Yes, it can happen. It is happening in today life. It is happening. What do I want to tell you? Here remember, no. So, did you understand? Motion, rest. Any object is in rest. Any object is in rest, will be in rest. Now time will be passing, but object will be in rest. If object is moving, it means object motion of that object is taking time. Okay, that object motion of that object is taking time. If object is moving, then we can say motion of that object is taking time. It happens. Clear? Now shall we understand effects of force? Yeah, effects. It's a time to understand effects of force. What are effects? Effects here, always remember, by applying force By applying, we understood by applying force, we can we can change state of object which is in rest. Yes, it can be, it can it can happen. Yes, we can change state of object by applying force. It is a effect. It is one effect. Now, by applying force, any object can be stopped if object is in a motion. This is second effect. Clear? Moving speed of a moving object can be increased. It is also effect. All these are facts, not fakes. All these are facts. All these are happening in world. Now, a speed of a moving object can be decreased. Yes, it can happen. A speed of moving object can be increased. Yes, it can also happen. It can also happen. Clear? What else? What else? Now here, can you change direction of direction of a moving object in any direction? Can you change? Anybody can change. So can we say it is effect of force because of by applying force, direction of any object can be changed. Can be changed. It happens. It is happening. It will happen. It can happen. So remember, it is also effect. Can we say by applying force, yes, by applying force, direction of any object can be changed. Can be changed. Here, but by applying force on any object, you cannot change mass of that object by applying. Clear? Yes, you can change dimension. You can change length of any object. You can change dimension of any object. Clear? These were effects. Of force. Now, what is the SI unit of a force? Also remember, SI unit of a force is what? SI unit of a force is Newton. it is represented by a node. As we use a kilometer to measure something, to measure weight, okay, kilogram, not a kilometer. Kilometer is used to measure something length. Is a same here. SI unit of a force is a Newton. If we say 10 Newton, it means 10 Newton is a force. 10 Newton force we are applying. Okay. So this is a SI unit of a force. Now, what about the quantity? What about the quantity? Which quantity is a force? Which quantity force is? You would say vector. Why? Why? We are saying vector. We are saying that force is a vector quantity. So it means force will have a direction. Yes, of course. When we push something, so direction you can observe of that object. When you push something, so in which side you are pushing, you will get what? Direction. In which side you are pulling, you are getting direction. In which side you are pushing, you are getting direction. That's why force is a vector quantity, because it has a magnitude as well as vector. For example, 10 Newton in north. So 10 Newton, where 10 is a number and n is a unit, north is a direction. So can you say 10 Newton is a magnitude and north is a direction? So this whole will explain that it is a vector quantity. Force is a vector quantity. Now next let's understand balanced force and unbalanced force. Balanced force and unbalanced force. What is it? It is telling you balanced force will be equal to 0. What is the meaning of this? If this side is how much? 100 Newton, and this side is also how much? 100 Newton. So both are equal. Both are equal. Can we say this side is 100 and this side is how much? 100. So both are equal. Both are equal. It is what? Balanced force. Balanced, which means both sides will be balanced. Both sides will be equal. This side is 100, this side will be 100. If this side is 90 and this side is 100 Newton. So what is happening here? This side 10 Newton is more. Now object will move this side. Object will move this side because of 10 Newton is more in this side. That's why object will move in this direction. Clear? So it is not a balanced force. It is a unbalanced force. This is a balanced force because of both sides are equal. Always remember. Always remember. What about this? This is object. Clear? Now one person is applying 10 Newton force on this, and the second person is also applying 10 Newton. So here you are observing total are how much? Both are in one direction. Total are 20 Newton. So 20 Newton is unbalanced force. It will not be equal to 0. Unbalanced force will not be equal to 0. One person is applying 10 Newton force on this object, and other person is also applying 10 Newton force on this object. So both sum of this will be how much? 20 Newton. Both are applying 20 Newton force on this object. Clear? Of course, yes. Clear. So remember, if this side there are two person and both are person applying 20 Newton. Now what if this side one person is applying 5 Newton. Now what will happen? Here this person who are this side will move this, and this person is also applying force on this object, but this object will move this side because of here is a 20 Newton and here is less Newton. That's why this object will move this side. It will work to decrease speed of this 5 Newton will work to decrease the speed of this object. Now what if second person came immediately and he applied 15 Newton. Okay. Now what will happen? Object will not move at all. Yeah, it is that. You can observe carefully. Both sides. Between is what? In between is a object, and both sides are two persons. Each of both persons in both sides applying 20 Newton. This side also 20 and this side also 20. Both are equal. That's why object will not move at all, because of both are equal. If this side is 20 is equal to this side 20, so both are equal. Now we can say it is a balanced force because of balance. What is the meaning of a balance? Both sides will be balanced. Both sides will be equal. This is the meaning of a balance. Clear? Now, only 15 Newton. Only 15 Newton. Now it is not balanced force. This side is 15 Newton and this side is 20 Newton. Both sides are not equal. That's why we would say it is an unbalanced force, because of it is not equal to 0. Both sides are not equal to 0. Both sides are not equal. That's why it is not a balanced force. Clear? If there is a balanced force, this side, both are same. So meaning of this would be what? Object will not move at all. Yes. Whether it is in a state, whether object is in rest, whether or object is in motion. If object is in motion and both sides force of 15 Newton is being applied both sides, so object will move same at initial speed. Nothing will happen that object which is moving. Nothing will happen because both sides, force of both sides are equal. That's why nothing will happen with that object. Clear? It is the meaning of a balanced force. There is a balanced force. It means nothing will happen with the object. Clear? If there is an unbalanced force, so there will be change with the object. There will be change on object. Here you can see this side is a 20 Newton and this side is a 15 Newton. Now, of course, now it is not a balance, rather it is a unbalanced. Now, if it is a unbalanced, of course, we can say object will move in particular direction. Do you want to see in which side? this object is moving. Do you want to do see? Here you can see this is a 50 Newton and this is 20 Newton. Always remember, if in one side Newton is more and in other side Newton is less, so more Newton which is one side, so that object will move in that side. For example, here you can easily see in this side is how much Newton, 20 Newton, and this side 15 Newton. So this side is more, of course you can see this side is more, so you can say, and object is not being pulled, object is being pushed. So if object is being pushed, it means here this object will move this side, because of, so here I was wrong. If in one side Newton is less, then that side object will move. Here you can see this Newton is less as compared to this Newton. When this two persons will apply 20 Newton force on this object, and also this person will apply 50 Newton force on this object, so it is a more and here it is a less, so of course this object will move in this direction, Why? Reason is that it is a less, this Newton is a less. Okay, this side force less force is being applied, this side less force is being applied, that's all. Now this is object, it will have mass, let's say this is how much, let's say 50 kg, it is how much, it has a 50 kg mass. Now this side nobody is applying, force on this object, only this side two persons are applying, force of 20 Newton, only this side, not this side, only this side. Now what will happen? Something will happen, something crazy will happen. Here this object will move this side and object has a 15 kg mass. Object has a 50 kg mass. Now this object will move this side and it will move with a speed. Now this side one person is applying 5 Newton, this side, and this side two persons are applying 20 Newton on this object, and this side one person is applying 5 Newton on this object. Now what will happen? A speed, you will observe a speed, you will observe a speed. Then this was not there, here, and only this side two persons were applying 20 Newton force on this object. A speed of this was something constant, you can say something 5 meter per second, you can say 5 meter per second. Yes, otherwise you can say 6 meter per second. Yes, 6 meter per second. Now a person came in this side and he applied 5 Newton force in this direction. Now what will happen? Try to understand here. What will happen? 20 Newton force is being applied in this side on this object, and 5 Newton in this. So now a speed of this object will decrease because here 5 Newton force is being applied on this object. That's why a speed will decrease. You would say with a speed of 4 meter per second, this object will move. Now, second person, this same person, he applied how much? 10 Newton. Now what will happen? Now what will happen? Here you can say, initially this person was applying 5 Newton, and now initially a speed was how much? 4 meter per second when he was applying 5 Newton force. Now he increased Newton. Now he is applying 10 Newton. Now what will happen? Here a speed will also decrease, will more decrease. Now a speed of this object will be how much? 2 meter per second. In 1 second, this object will cover 2 meter. In 1 second, this object will cover 2 meter. Initially, it was covering how much? In 1 second, 4 meter. In 1 second, 4 meter. But now it is this object is covering 2 meter distance in 1 second. Why? And here a speed decreased. Because of this side 10 Newton was applied on this. That's all. Clear. Now this side here is a nobody. Okay, here in this side is nobody. 20 Newton. Nobody will have. I increase how much? Let's say 50. Now this is 60. It means a speed of this object will increase. You can say 7 meter per second. It means in 1 second 7 meter is being covered. 7 meter distance is being covered in 1 second. This is the meaning of this. So here I increased Newton how much? 50. Now this side 60 Newton is being applied force on this object. This object will move fast. Okay. Now what if Newton is the same, but I want to increase mass of this object? Let's say 35. Initially mass of this object was 15 kg. Now mass of this object is 35 kg. Now what will happen? Yes, you are right. A speed of this object will decrease because I increased mass of this object. That's why I didn't apply force in this direction. Only I increased mass of this object. Now a speed of this object will decrease. Why? Because I increased mass of this object. That's why. If I decrease mass of this object, then a speed of this object will increase. So you can say a speed also depends on mass and opposite direction. So all this that we are understanding, it is a unbalanced force. We understood if we increase Newton and if we don't increase the mass of any object, only we are increasing force. So of course motion of object will increase. If we increase mass of an object and we are not increasing force on that object, then what will happen? Motion of that object will be slow. listen. On object force is being applied. Object is pushing. Object is being pushed. Now other side, in opposite side, some persons are applying what force in opposite direction. What will happen? Yes, motion of that object will take. It happens. Okay. From this we understood balanced force and unbalanced force. Now next topic, next concept. Let's understand. Next is inertia of rest. This is the next topic. Here try to understand. We are understanding laws of inertia. Law of inertia. We will understand three types of inertia. Meaning of inertia, but it is a lazy. Object will be lazy. Inertia, which means lazy. Sometimes we don't want to do work. We feel lazy. It means we are feeling lazy. Okay, that's it. We get big projects, big work. Then immediately we feel lazy. Yes. It means we don't want to work. Same here, meaning of inertia is what? Lazy. Lazy. Okay, meaning of inertia is lazy. Let's start. So these three are laws. These three are laws of inertia. And here all this, meaning of all this will connect with the Newton's law. Will connect with the Newton's law. So let's start from inertia of rest. Here word rest is coming. What would you like to say? Word rest is coming. I would say let us say object is in rest. Object is in a rest. This is what it is telling us. This is telling us. Object is in a rest. And now we understand inertia of rest. Object is in rest, will be in rest, was in rest. Are you understanding what I am saying? Object will be in rest. Object is in rest. Object was in rest. Object will be in rest. It is a meaning of. This is a definition of inertia of rest. It is directly telling you object is in a rest, object will be in a rest. But when it comes to external force, then something will happen. You can say impact will be seen. When external force will be applied on object which is in a rest. Object wants to be in a rest, object which was in a rest already, and that object wants to be in rest, but when external force is applied, then that object is being disturbed, that object wants to be in a rest, and we are disturbing that object. This is why, because due to inertia of rest, object will be in a rest until unless external force will be applied on that object. It is also definition of Newton's first law. But let's complete this. Remember, object will be in a rest, but when external force will be applied, then that object will come into motion, and it happened due to inertia of rest. Already object was in rest, but when external force was applied on that object, then that object came into motion, and it happened due to inertia of rest. Now, meaning inertia of motion. Inertia of motion. There are a lot of objects that are in rest. This board is an example of inertia of rest. There, I am not in rest. I am moving. Not I am moving with a spirit. I am not in rest. I can be an example of inertia of motion. Not inertia of motion. Not completely. There are a lot of objects that I can see which are in object, which are in a rest. All these objects will be in motion. But when it comes to external force, if external force will be applied on object, then of course that object will come into motion. It happens. It is a nature. It is nature. That's why we are saying it is a law of inertia. It is a law. It is a law of inertia of rest. Now next, fan is moving. It is moving. Okay, fan is moving. It is not. We can directly say that fan is not in a rest. It is moving. It is moving. It will be moving. But when external force will be applied, then there will be impact of this fan. What will be impact? That moving fan will come into motion. This is it. Now it is an inertia of motion. Why? Because object was in motion, and when external force was applied on this object, then it came into rest. Due to inertia of motion. Clear? Now, inertia of a direction. Direction is the same. Okay. Motion of any object is moving. Object is moving. Okay. But object is moving in same direction. Then we would say that is an example of inertia of direction, because of object is moving in same direction. When that object takes a turn, it means that object is taking direction. That object will move in different direction. So it happened due to inertia of a direction. Now that object will turn into different direction because external force will be applied. Then it will happen. Then object will turn into direction when external force will be applied. Okay. So from this you are observing one common word: external force. External force. You are observing external force. Object, in this case, object will be in rest. In this case, object will be in motion. In this case, object will be moving in same direction. But when external force will come into picture, then external force can change can change state of object which is in a rest. External force can change motion of object. External force can change direction of any object. So, are you observing something? Are you observing something? We have understood all laws of inertia. All laws of inertia. Now here, mass. What about mass? Always remember. Always remember. If Newton is less and of mass of object is more, then of course we will apply more force because mass of object is more. That's I wanted to show an example. Let's say this is a box. Mass of this is how much? How much? I think so 20 kg. And one person is applying how much? First 20 Newton. Not 20, 10 Newton. 12 Newton. Okay, 12 Newton. Mass of this object is 30 kg and 12 Newton force is being applied on this object. Now, this is happening, clear, okay. We are understanding mass. If we increase mass of this object, now mass of this object is 120 kg and Newton force is the same. Now what will happen? What will happen? We will not be able to move this object not as we were moving inertially. As we were moving inertially this object. Now, inertially mass of this object was 20 kg. Now it became how much? 120 kg, and force is the same. So of course we will apply more force. Why? Because mass of this object increased. That's why. So remember, if a mass of an object increase, then we will increase Newton. We will increase force. Okay, we will increase force. You can say force will be directly proportional to mass of that object. Mass of that object. If mass of this object is decreasing, then we will apply less force. Of course, we will apply less force because mass of object is less. That's why. If mass of object will be more, then of course we will have to apply more force so that we can lift the object, so that we can push object, so that we can hold object. If mass of object is more, then we will apply more force. So if mass of any object is less, then we will apply less force. This is happening. Okay, so you can say we can be depend on mass. Okay, we can be depend on mass. We will think that mass of this object is very high. Then we will do one thing. What? We will apply more force. If mass of this object is less, we are assuming mass of this object is less, not too much. Then in our mind we will think that I will apply less force and it will move. It happens? Yes, it will happen. So what are you understanding? If mass of any object is more, so we will apply more force. If mass of any object is less, then we will apply less force. Clear? Now, here 110 kg. Mass of this object is 110 kg. How? Inertia of this will be more. Inertia of this will be more. Density of this object will be more. That's why we have to apply more. Now inertia of this object is more. We can say this. We can say it. Now next topic, Newton. Newton first law. Newton first law of motion. Here we will explore three laws of Newton. Newton's first law of motion, second law of motion, and third law of motion. In first law we observe what? In this we will observe what? We see what? How force is being applied on object. We see in first law of Newton. In first law of Newton. In second law of Newton, we will observe what? How to calculate how much force is being applied on any object, how to calculate it. We will explore in second law of in Newton's second law. We will explore. In Newton's third law, we will explore nature of force, nature of object. Otherwise, you can say nature of force. It's nature of. In first Newton's in Newton's first law, we will understand. We will explore that force is being applied on object. We have understood meaning of this Newton's first law. Where? Here. Now again I would like to repeat definition of this. First law of Newton, it explains that any object will be in motion, any object is in rest will remain in rest. Any object is in motion will remain in motion. But when external force will be applied on object which is in rest, then that object will come into motion. If object is in motion, then external force will be applied on that object, then that object will come into rest, and that object can be increased, the speed of that object can be increased. So it will happen when external force will be applied. But if we are not applying external force, then that object will be in motion, that object will be in a rest. Object is in a rest, will be in a rest if we are not applying external force. Object is in motion, then object will remain in motion if we are not applying external force. If we apply external force, then you will see impact of both objects. Clear? In Newton's second law, we will explore how to calculate how much force is being applied on any object. We will explore in second law of Newton. From third law of Newton, you will explore nature of the force, reaction and action, action of reaction, reaction of action, reaction of action. In this law, you will understand how did F came as m? F is a force, m is a mass, and a is acceleration. A is acceleration. Meaning of this is what? Meaning of this is what? It is telling you when we will apply force on any object, then of course object will have mass. Of course object will have mass. And when we will apply force, then object will come into motion. Yes. And now object is increasing a speed. If we are increasing a speed of object or if we are decreasing, then we can see a lot of times what happens, there will be changes, there will be changes in a speed of object. So that a speed, that is velocity. If there is a change, of course object will not be moving in only one direction. We were understanding just to understand, but we see in a real life, but a lot of objects moves, a lot of objects take a direction, a lot of vehicles increase a speed, a lot of vehicles decrease a speed according to need. Yeah, it is happening, it happens in a real life, isn't it? That's why we are taking acceleration, in which we can say a speed of any object is increasing or decreasing. Initially a speed, initial velocity will be something else, and final velocity will be something else. Then from this we will find what was the change of velocity, what was the change, a small change we will find. So here from this you are understanding, when we will apply a force on any object, that object will have mass, and now of course acceleration, that motion of that object will accelerate. Yes, it will happen. Now it is said do you know momentum? What is the momentum? It is a mass. Momentum, which means P is equal to A B. B is velocity. We will understand this later. M. Yes, velocity. So here you will observe momentum. Mu initially speed of object, and final, not initially and final and initially speed of object. Upon time, of course, it will take time. Delta T. It is the state. Now, meaning of this is what? It will depend on this. If time will increase, then momentum will increase. Okay. Now here we can easily write, in this we have common m as a common upon it. So time of this will be this, and second time 1. Clear? What else? Here this upon this, it is given as a acceleration, as acceleration. Delta P upon delta T is given as force, and M as it, this upon this is given as A. That's how it came. F is equal to A multiple A. We will explore it in details in separate lecture.